Newton's law of cooling. Dish of lasagna baked at 400 degrees Fahrenheit, taken out of the oven into a kitchen, 68 degrees Fahrenheit for the kitchen. After 6 minutes, the temperature of the lasagna is 340.4 degrees Fahrenheit. When will its temperature be 270 degrees Fahrenheit? Round your answer to the nearest minute. So Newton's law of cooling, and it's going to look something like this. I'll just write it down just in case we haven't seen it, and I'm going to borrow heavily from my notes because this is a fun equation. T minus Ts is equal to the initial temperature minus Ts times e to the negative kt. All right, and basically these all stand for different things. This guy right here is your final temperature. Okay, he's your final. So that's the temperature we're interested in being at the very end. Okay. This guy right here is your surroundings. So this is the temperature of your surrounding items. This guy right here is your initial temperature, or in other words, what we originally have to start with. K is just some constant, and it doesn't change. Once we find it, it stays the same through the whole problem. And the little t here is time. So we've got all these things going on, and basically what we're going to have to do is solve this equation twice in order to get to how long it'll take for the temperature to cool to 270. So for the original problem, and I'll work the original problem in green, for the original problem, our final temperature, okay, is 340.4 degrees, okay? So that's going to be 340.4. The surrounding area temperature is 68. The initial temperature is when we pull it out of the oven at 400. The surrounding area is, again, 68. E to the negative, K we don't know, but time we know is 6 minutes. So 6K. So that's what this guy looks like. So I'm going to borrow from my math here. This is going to be, gosh, I didn't write it down. How unfortunate. So 340.4 minus 68 is 272.4. And 400 minus 68 is 332. Go ahead and divide those guys out. And when you divide 272.4 by 332, you end up with, and here's where you want to carry as many decimals as you can. Comfortably carry 82048. That equals e to the negative 6k. And what happens with this then is that we can rewrite this in natural log form. We can rewrite this as a natural log, or you could take the natural log of both sides, or however you want to imagine it happening. But basically what we're going to do is we're going to have the natural log of 0.82048 equals, and this is what's interesting, the natural log of e to the negative 6k. If we take the natural log of e, it cancels itself out, and the only thing that's going to be left is going to be 6k. So I have natural log of 0.82048 equals negative 6k. Divide both sides by negative 6, take your natural log, and you get k to be 0.03298. It's a really ugly zero, so let me just make a little small pretty zero here. Now, that's part one. We've got K. So what we want to do is now we want to find out how long it will take to get to 270. That's our new final temperature. So I'm going to let 270 minus the 68, that's the surroundings, equal the starting temperature now. Well, that's when we pulled it out of the oven at 400 degrees, minus the 68. Times e to the negative t. We don't know this time. Okay, we have no idea, but we just discovered k. K has to be the same the whole way through. It's going to be 0.03298 times t. And we're going to solve this problem out the exact same way we solved the previous one. 270 minus 68 is 202 degrees. 400 minus 68, well, we did that one earlier. That's 332 degrees. Okay. Divide both sides by 332. And when you divide both sides by 332, you get 0.6084. The more decimal places, the better. All right. E to the negative 0.03298 t. Again, we're going to take the natural log of both sides. So the natural log of 0.6084 is equal to negative 0.03298 t. For the same reason over here that when we took the natural log of both sides, the e's cancel. When you divide both sides by that negative 0.03298 t and you take the natural log of 0.6084, you end up with 15 minutes. Okay, so using Newton's law of cooling, how long does it take for our lasagna to get to a temperature that we can handle? It takes 15 minutes.